our rational expressions today. All right, so to simplify a rational expression, just like a rational number was a number that could be written as a quotient of two numbers, division problem, a rational expression is something that is the division of two expressions, so algebraic expressions. So what we're going to do for these is we are going to, if necessary, factor the numerator and the denominator, almost like you have two separate problems. And then you will divide out any common factors. And a lot of people refer to that as canceling, like in the top and the bottom. Okay, but they are dividing out because you have the common number in the top and the bottom. And then you do want to simplify any remaining factors. Like let's suppose you had 2x over 4. We can reduce that to be 1x over 2. So always simplify. And then we are going to state any restrictions on the variables today, which we did way back when in I think chapter 1 when we did solving literal equations that had all the variables. So remember, the restrictions on the variables are just that the denominator cannot be 0. So like if you get x in the denominator, you would just say x cannot be 0. It can be any number besides 0, but if 0 were to be plugged in, then you would get an undefined expression. All right, so we have several different types of problems, and just like looking at these right here are monomials. Reviewing some vocab from last year. Monomials have one single term, okay, being multiplied together. Okay, this right here, this is a binomial. Whenever you see a binomial, there's technically imaginary parentheses around it. You may want to put them in to make sure you realize the only time you can cancel or divide out a binomial is if you have a matching binomial in parentheses in the numerator or denominator. And then does anyone remember what these are called in terms of a polynomial based on the number of terms it has? We had a monomial, a binomial. What would this be? Yeah? A trinomial. So usually when you see a trinomial like this, we're going to factor it like we've been doing into two binomials. And then we may have common binomials in the top and the bottom that will divide out. All right, now the first one, when they're monomials, you usually just want to use like division. So 21 divided by 7 is 3. Technically 3 over 1, if you wanted to think of it like that. Now do we remember our exponent rules? If we have division of exponents, what do we do with these numbers? We subtract them. And again, they have to have the common base, so since they're both a's. 2 minus 3 would get me a negative 1. Well, let's just put this over here. And then do we remember what we do with negative exponents? Hannah? Good. It changes location. So a to the negative first would go to the denominator, and once you do that, it becomes a positive. So this would be 3 over a. Now, let me show you an alternate method that you can do this if you don't like that. You can actually expand this or kind of factor the number 21. You could make it 7 times 3 and then make a squared a times a. So if you'd like, you can expand it. In the bottom, I would have 7 times a times a times a because it was a to the third. And then you can divide out common factors. So obviously the 7s would divide out. These two a's would divide out with those two a's, and you'd be left with 3 over a. Some students like that better. But obviously, if it were like a to the 12th, you'd have to write out 12 a's. Okay, the next one has a combination. We have a monomial in the top. We have a binomial in the bottom. And again, you want to make sure you group the binomial or trinomials with parentheses. So in the top, I can't really factor anything out. I could expand it to be like 9 times 2 or 6 times 3, right? But in the denominator, is there anything that I can factor out of 4d plus 8? Ashley? Good. We can take out a GCF, 4. And so we'll have 4 times the quantity d plus 2. And just thinking this through, like we know we want to reduce some numbers. You might want to break 18 down into 2 times 9, or we can just reduce 18 fourths to be 9 halves. But if you want, you could break this down into be like 2. Well, let's just leave it. You know what? Let's just leave it. So the only thing that can be simplified at this point is 18/4 as a fraction. They both are divisible by a factor of 2, so we would reduce that to be 9/2. And we actually cannot, and I forgot to do the restrictions, we'll go back there in a second. We actually cannot cancel anything out any further, okay? This is d plus 2. The inverse of addition is not division. So this would be as far as you can go. Okay, now restrictions on the variables, and we'll go back since I forgot it on example A. Remember, the restriction is just that the denominator can't be 0. So here's our denominator. The 2 we obviously know can't be 0, but d plus 2 cannot equal 0. And we'll solve for d using inverse operations. So we'll subtract 2 on both sides to get that d cannot equal a negative 2. That's our restriction. If d were negative 2, plug that in, you would get 0. Any other number would work. Back here, the denominator was just a, so our restriction would have just been a cannot be 0. Just whatever's in the denominator. The numerator can be anything it wants, it's just that denominator. All right, the next one we have 2 binomials. Again, anytime you see a binomial, you probably want to put parentheses around it to realize that you cannot just start crossing stuff off. Okay, that's a mistake students make. They start canceling things where they're not allowed to. So in the numerator, there's no GCF, so I'm just going to leave it as is. In the denominator, I can take out a factor of 3, right? The only time you're allowed to cancel things that are binomials is when they're exactly the same binomials, so the whole parentheses. Okay? So we can divide these out. Our answer is not 3, though. There's technically an imaginary 1 in the top, right? So that would be 1/3. Make sure that you don't think the answer is 3, because 3 is in the denominator. This would simplify down to be 1/3. Now, you still need to state restrictions from the original one. So even though our final answer doesn't have 1, and if we had gone up here and subtracted 8 divided by 4, we would have got the same 1. But you would want to still state a restriction on the original one, which could be this one or this one. It doesn't matter. You'll get the same answer. This is a little bit easier. So we'll say 2n minus 3 cannot be 0. 2-step problem here. Add 3 to both sides. And divide by 2. And so we'll get that n cannot equal 3/2 or 1.5 will be a restriction. You do have to look at the original for restrictions. Now example D and E, we have some trinomials. Again, trinomials are still grouped technically. Oops. Imaginary parentheses there, grouping them together. Now trinomials, we're going to factor each of those into 2 binomials. Chances are you're going to have a matching binomial too, so that can kind of help guide you with your factoring. So in the top, and both of these are simple factoring problems. Since A is 1, I'm just looking for numbers that multiply to get me -6 and add to get me a -1. So what would I factor that top trinomial into? Numbers that multiply to a -6 and add to a -1. What would I pick? Hannah? Good. -3 and 2. -3 times 2 is -6, -3 plus 2 is -1. Excellent. Now in the denominator, we're going to factor looking for numbers that multiply to 6, either 6 and 1 or 3 and 2, and add to 5. So that's going to be +3, +2. We can divide out, since this is multiplication and this is division, those are inverse operations, you can divide these out. Now the mistake I'll see students make is they think they can cancel these C's. You cannot do that. Okay, this is C minus and then division. The inverse of subtraction is not division. So those do not divide out. This would be our final answer. C minus 3 over C plus 3. And you might want to leave parentheses just to remind yourself not to go cancel crazy, or you start canceling all stuff you're not allowed to. And this is something that you'll have to do in pre-calc, calc. Mrs. Cotton screams about it. They think they can cancel everything. You don't want to cancel things that are not inverse operations. Now, when we do our restrictions, we do want to do them on even the one that we divided out or canceled out. So we do have two restrictions here. We're going to have c plus 3 cannot equal 0, and c plus 2 cannot equal 0. Remember, when you're doing restrictions, the only thing you're focusing on is the denominator, but it does have to be the original denominator, which had the plus 2 in it. So we'll get two restrictions here. C cannot equal negative 3, and c cannot equal negative 2. Two values that cannot exist. Okay, last one on the front here, we have a binomial and we have a trinomial. Anytime you have a binomial, you really can only take out a GCF. You can't factor it into two binomials. So I could take out a 2. And the denominator, the trinomial, gets factored down into two binomials, just like you've been doing on your homework. So two numbers that multiply to a negative 4 and add to a negative 2 would be what? Multiply to a negative 8 and add to a negative 2. Ashley? Good. Oh, now I'm putting C. Negative 4 and positive 2. And you guys also might want to use the numerator as kind of like a guide. Like one of them's probably going to be x minus 4, right? So that they have common elements, typically. And then we can divide out our common binomials, and we're left with 2 over the quantity x plus 2. You cannot cross off these 2's. I repeat. You cannot cross those off. And again, it may help you just to keep that group to remind yourself about. So we should have two restrictions here. X cannot equal a positive 4, because it would be x minus 4 equals 0, add 4 to both sides. And also cannot equal a negative 2. Why don't you guys try examples A and B on the back? We'll do C together just since it's a little bit different. But see if you can try A and B. There's there. And we should be left with the final answer is x plus 5 over x plus 4. And our restrictions here would be x cannot equal negative 4 or negative 5. How about for B? What did you guys get for your final answer here? Hannah?
Negative 3 over x.
Perfect. Negative 3 over 1x, or just x. Very nice. And for your restrictions here, you actually should have two. We should have that x cannot equal 0, and also that y cannot equal 0, because there was originally a y in the denominator. All right, now the only thing that makes the last one in the top row a little bit more challenging is the top part, which is not really in standard form. So you probably want to rearrange it first to make it negative 3x minus 6. Otherwise, you're not going to find common elements in the numerator and denominator. Then we could take our GCF out, which would be a negative 3. And when you do that, you will get x plus 2 inside of your binomial. Then factor your denominator. Multiply this to 8, which will be 4 and 2. And they both need to be negative. Uh-oh. Nothing cancels. Oh, I changed it. Does yours have a change sign or no? Okay, change that to be a positive 6. Otherwise, we don't get anything to cancel. Sorry. I have that written on my paper to change, and I never changed it. All right, now we factor this down into, if that were to happen, you just wouldn't be able to cancel anything out. That doesn't really usually happen unless I type something in. And then we can divide out our common elements. And so we get negative 3 over x minus 4. And our two restrictions would be x cannot equal, we would add 2, so that's a positive 2, and a positive 4. All right, so you guys can try D, E, and F, and then we are going to go over one of these harder ones that has multiple variables. All right, and then the last one we'll do together is example G. This was actually a study island question. Did you guys used to have to do study island in middle school? this was where I got this. These were some Keystone test prep questions. And you also see a lot of, this stuff shows up a lot on the SAT, at least on the SAT practice test that they post. They love rational expressions. So what we're going to do is obviously the same thing we've been doing, but what will make it a little harder is the answer we get is not going to be a choice. So we're going to have to simplify it a little bit further. So first of all, in the numerator, what would be the GCF up here? Amongst that trinomial, Hannah?
XY.
Good. The GCF would be XY. So we'll factor out an X and a Y from each term. So that would get me, again, when you factored out, you're dividing it. The X's would divide out. We'd be left with just 2Y minus X squared divided by X. We would subtract those to get 7X. The Y's would cancel out. And then we'd have plus 5XY. Now the denominator, you can leave it X squared, Y squared if you want, or you could expand it to make it X times X and Y times Y, just to be able to see canceling a little bit easier. But you could also use your exponent rules, which would just be to subtract. So one of those will cancel out and divide out, and one of these Y's will divide out. So we're left with 2Y minus 7X plus 5XY all over XY. Our restrictions, of course, would be that X and Y cannot equal 0, neither of them. Problem is, none of the answer choices look like that. Okay, so how you can simplify from here, if you have a big fraction like this with multiple elements in the numerator, you can actually split it up into 3 separate fractions, all having a common denominator. So really, this would be 2y over xy minus 7x over xy plus 5xy over xy. So to simplify, you're really splitting it into 3 fractions. And then we will be able to simplify a couple things out once it's split. So these y's will go away, these x's will go away, and the x's and the y's will go away at the end. So I'm left with 2 over x minus 7 over y, plus 5, which would be answer choice B. Okay, see if you guys can try the closure real quick. Remember, anytime you see a negative in the front of an x or an x squared, you always want to factor out a -1 first and see if you can answer that while I'm passing out your homework. Again, make sure on the back of your homework that you do show work, not just circling the answer.